Thank you.
Yep.
All right, judges, are you guys all ready? All right, UTRGV, are you ready?
Yes, we're ready.
All right, you may begin.
Hello, my name is Leslie Garcia, and alongside me are Lisbeth Campos and Mayra de Santiago. We will be going over Infreda's infrastructure design and components.
With a focus on the megacity, Infreda looks to improve the living conditions of the population. It would also address issues related to high population, like minimizing congestion and urban sprawl. Not only that, but it would also facilitate higher income opportunities with the incorporation of a public transit system.
So Infreda's proposed underground tunnel system that combines two infrastructure projects, which are a roadway system and a mass transit system. And Infreda will take traffic congestion below ground and help reduce time needed to travel. It'll also help reduce auto pedestrian accidents seen in cities today by eliminating the need for people and vehicles to share the same road. Infreda is composed of two underground tunnels, which have two decks in each. So the top deck is reserved for vehicles, and then the bottom one will have a 24-hour subway transit system. This will allow for practical use of above ground level by promoting eco-friendly and sustainable project development at the surface level. Aside from this, Infreda can aid in preserving historic character present in the city, along with the boosting economy and labor market.
The top deck will be reserved for one-way traffic and is primarily reserved for personal vehicles. Each tunnel would have traffic going in opposite directions, and this deck will reduce the amount of time it takes to travel 1 mile, as well as alleviating traffic congestion expenses. The bottom deck, on the other hand, it would consist of only the subway transit system that would be available to the public with the incorporation of a subscription system. This subscription system will be made affordable to the middle class and lower class citizens who may not have reliable or personal transportation.
The proposed megacity can be closely envisioned from what has already been seen in large and heavily populated cities in our present day. From research conducted in 2011, it's been seen that traffic congestion, which Infreda targets to resolve, had cost the American average commuter $818 in lost time and fuel. And according to a US Department of Transportation report, within a 20-year period, it's been seen that there's been an estimated 50% increase in congestion severity in urban areas. And upon seeing this trend, it's safe to assume that there will be an issue with the proposed megacity.
Infreda will help minimize traffic congestion and reduce travel time. With the incorporation of a subway transit system, Infreda encourages people to use public transportation. From data collected in 2011, the public transit system saved the American economy $20.8 billion. Additionally, sustainable public transport systems help to alleviate greenhouse gas emissions, so the carbon footprint of the human population will be reduced.
Infreda will require the use of tunnel boring machines to dig through the underground composition of rock and soil while simultaneously placing the concrete tunnel lining with a 12-meter diameter. The tunnel will stretch for 1 mile, 30 meters beneath the surface, and depending on how much the city demands for transportation aid, more tunnel can be added. This would be a unit measurement, and it would include the 2 lanes with additional space for vehicles that may break down.
For the health and safety, the tunnel would have an air quality control system. It would also have a video monitoring system, emergency exits, and water sprinklers to enforce safety precautions, of course. The tunnel would also have a wheelchair accessible. It would help promote inclusivity. Additionally, considering the recent and ongoing COVID-19 pandemic, it would be required that the tunnel will go through a bi-weekly sanitation to help reduce the spread of any viruses or diseases.
Infreda allows people to go out and work knowing that they will have a steady and reliable transportation system. And it is anticipated that there will be an estimated 5 million daily transit commuters. And with that, it is expected that the costs remain reasonable to be able to make the transit system easily available to low or middle class commuters. Because Infreda is such a large-scale project, it will require that stakeholders are willing to contribute a major amount at the start for construction, but should be assured of the profit that will exceed what they initially contribute. There will be an expected profit of more than 400% by the first year to make up and exceed the one-time cost to build, as well as the yearly expenses such as maintenance and miscellaneous expenses. Infrared is constructed to be able to withhold a long lifespan and be able to adjust to any new societal norms seen in the future, such as advancements in primary modes of transportation. Are there any questions?
All right, thank you guys. I do have one question so far. How would you guys design your exit and entrance ramps? What's your idea for how people actually get into the tunnel to drive?
So the entrance and exit ramps, they would be kind of in a sense, because obviously the tunnel would be below ground, right? I would suggest that the design be, I guess, from regular surface level, angled downwards into the tunnel. And then because we are stating that there's going to be two tunnels, one tunnel going this, having traffic going this way, and then another going that way, we would design like, I guess, one main road that would divide into two, kind of directing like the direction of traffic, just to, how do you say, revolve around what's already given in the megacity.
Okay.
So I'd like to build on that question. So I'll start there. I have lots of good questions for you guys, but I'll start here. So along that same line, when we're talking about a megacity, we wouldn't just be doing 1 mile of this tunneling system. It would be hundreds of miles across this and underneath this entire megacity. Have you guys made an estimate of approximately how many miles would be necessary to support 50 million people, a city of that size? And how many exits and entrances do you need along that entire system?
Okay, so with what we've gathered and presented, we presented it in terms of 1 mile. So all these estimates, again, are based on 1 mile. And I know that it would be encouraged that we create like a longer tunnel system, but I also don't want to promote like, because in all, we're promoting like a healthy environment and such. And I know that if we do create such a long tunnel system, it might be damaging to the environment in terms of like groundwater and such. So I probably wouldn't recommend a long scale, but maybe 1 mile here, a distance of like above ground traffic, and then go back down for another range. And I feel, yeah, that'd be my answer to the question.
All right, Andrea?
So your premise is that it's going to alleviate congestion. And as we know, congestion exists and accidents happen on the road. So if we have this fully enclosed tunnel, how are you seeing maybe emergency services getting in to help those who have been in accidents?
Okay, so I do want to bring up again that we do have a video monitoring system. So that right away will let people who, I guess, keep up with the transit system, I mean, the whole tunnel system, sorry, they'll be able to say, okay, like we need to stop the traffic going into this tunnel and maybe redirect it into one that I know we did promote to be only one way. If it's a very severe accident, we'll redirect it to the other tunnel and turn it into a two-way, right? Obviously traffic would be going slower, but I mean, it's better than just being stuck in a tunnel, and it might be dangerous. It would be dangerous because there'd be there'd be a lot of stopped cars within one tunnel. But if it's not too major of an accident, like or a scenario where it's like maybe like a car just stopped working in the middle, there's 2 lanes and also additional space for like breakdown. So we could just kind of redirect traffic around that within the tunnel.
And one other thing to alleviate traffic, you said you have monitors, so are you monitoring and only allowing a certain number of vehicles in this tunnel for its capacity, so you're not just creating congestion in this tunnel?
Mm-hmm. So again, I know like I would assume in your city too that there's just hours of higher traffic, which would be maybe like morning rush, lunch hour, and then after work, right? So within those periods, I would be expecting that there's a lot of cars trying to use this tunnel, right? And with that, the video monitoring system, and then also just kind of, I guess, in keeping up with how many cars are going through this tunnel, we would regulate the speed during these times to make sure that it's not too fast for, to create like I guess to be safe about it, because we want to be going too fast where there's a lot of cars. And yeah, so we would be regulating the speed amount within the tunnel to make sure that there aren't too many cars at once within the tunnel, and also that just so that traffic keeps going for the most part.
Okay.
Did y'all think about anything related to utilities and
Utilities?
like any sustainable solutions to utilities, and how you would alleviate flooding and potentially maybe reuse some of that water for other areas utilizing your tunnel?
Okay, so in terms of utilities, like I guess I would assume that there's already utility lines like water and just a lot of wiring going on of a few feet below. That's why we would suggest that the tunnel be maybe 30 meters below surface, if not maybe lower, depending on the environment. I do also want to add that the tunnel is 2 decks, but there is space for the bottom. So maybe we could utilize that if it's more of a like area where I say like a flood prone area to avoid that. I have heard of systems in the past where they have done, I guess, smaller tunnel systems to redirect flooding. Like I know there's one probably like in the Philippines or the, where is it? Like in Kuala Lumpur. I know they have one there. Maybe we could kind of use those methods and incorporate into this one. But as of now, I can't say that we revolved our project around something like that.
Alexis, did you have more questions?
I do have more questions. Ladies, you guys did a really thorough job of explaining how you'd want to include both individual vehicles as well as public transit. So I have 2 questions that stem from this. Number 1, did you guys consider commercial traffic? So the shipment of goods on large trucks that often do the most damage to our current road systems. And the second question is, your revenue generation you have from your subscription model on the public transit. Did you consider charging individual drivers to use this, seeing as you'd more likely have higher income individuals using that version, just like a toll tag, and that population would have more disposable income to actually use your roadway? How would that impact your project?
Okay, so I did think about toll roads in terms of like the personal vehicles and such. I feel like these details like this would be discussed with the stakeholder just to, I guess, conform to what they want in their given megacity. So we didn't really go into detail on that, but it is something that we have considered.
Additionally, your subscription plan, I'm curious how you guys got to some of your suggested prices. Looking at the numbers that you guys shared, if you guys want to go back to that screen, your weekly rate actually is better than your monthly or annual. So you've de-incentivized users from using those longer term subscription plans. Is there a specific reason you chose to put them at those rates?
Yeah, so that's kind of more on, okay, well, in terms of like the set cost, I didn't want it to be too expensive. Like personally, I come from a low income family and I know how it's like to take like buses to places and stuff. I wouldn't have wanted to have like such a high price. And, you know, I'm putting my mindset in terms of what others would feel in that scenario. And so with that, let me look over my slide real quick. I do have it to where, I guess in a sense, we're promoting that people who aren't, I guess, from the area or maybe visiting, like let's say they're only here for the weekend, we'll promote like, hey, use our tunnel, like, you know, you're going to save a lot instead of going on like in a different route and stuff like that. I mean, so that they could use a public transportation system rather than something else that another individual group might be promoting. Let's see. And also I did try to keep the numbers revolved around the 150 like set price. But I also didn't want to be, I also didn't want it to be too insane of a price, I guess, subscription
Definitely
system.
Understood. So, but if I look at this math, if I wanted to, for example, use the weekly pass, if I want to do that every week for the entire year, 7 times 52 is actually less than your yearly price. So it makes more sense to me as a consumer to purchase a weekly pass every single Sunday and use it rather than have an annual pass where you can drive engagement with that user. So just a comment on the pricing structure. I think you guys clearly are headed in the right direction, but there are some opportunities to kind of refine here. So you guys get people to not only use the system but commit to using the system for longer points of time, so you can reap all the benefits.
I do want to add from that. I guess that goes back to I don't want to assume the situation that these people that I'm hoping that we'll use this public transit system. Like maybe it's possible, I mean, maybe they're not making that much income to be able to commit to something annually. So I kind of want to give them that option, like, okay, I for this month or this week, I will be able to use this transportation system. So I'll subscribe for the week and such. So that'd be, I guess, yeah.
I have one more question, Judge Eva, if I may.
Of course.
Awesome. So I'm a super enthusiast of tunnel boring machines, and I love that you guys brought this into your project. I have a couple of questions about them. Number one, these machines are very expensive and very, very large. They're hard to move. How do you plan to manufacture them in a way to where it's easy to get them to the project site? And is there, actually, I'll let you answer that one first. I've got more questions.
Okay. Well, as of now, I have heard of tunnel boring machines, right? That I wanted to incorporate that into the project and such, but I'm hoping that I know of, there's a lot of good ones and like that are German or, you know, from external, like they're not US made. So I'm hoping, or I would, you know, I was considering that by then there would be more within the US that we'd be able to use, because it wouldn't be something that we manufacture, it'd be something that we would be collaborating with someone who makes these to use for our tunnel system.
Okay, final question. You mentioned that you're going to have emergency exits every 35 feet along your tunnel. That's hundreds per a single mile. Did you use a standard when you determined that length? And did you consider those emergency exits in your calculations for how much this is going to cost and how you're going to make those emergency exits possible?
Okay, so I am going to be honest. I would have to look into more of the details in terms of like safety, saying like maybe, because maybe I put that as a number, considering like the length. I was assuming because I haven't personally been able to go through a tunnel to see if there are emergency exits even allowed, I mean, put within, because again, this is like a new concept. But yeah, so this, I guess, would be something that we would refine in our next draft of the infrastructure project.
Fair enough. All right, I concede.
All right, Andrea or Joe, do you have any other questions?
I have one more, if I may. So have you thought about like maybe repurposing your materials that you would use for construction? Like for instance, paving, you know how you can shred tires and use that to rubberize pavement and kind of do like an overlay. Have you thought about doing something similar to that and how you construct your tunnel?
Okay, so I'm gonna be honest. I did think about it, but I didn't want to stretch it too far in incorporating so many things to the tunnel. But again, that'd be something that we would be willing to consider if we have like enough research to back it up and make sure that it's safe for construction and such.
Okey doke.
All right, Andrea, did you have something else?
I do not. Thank you.
Okay. All right. Thank you guys so much. Okay. Next up, we will have UNAM.
Are you guys able to see my screen?
I see a black screen.
A black screen. Yeah, that's right.
Okay.
By 2050, the number of people that will have to leave their homes due to the sea rising level and will have to move to floating cities will be up to 140 million.
How will we feed these refugees in a sustainable and economic way in the middle of the ocean?
How will it be possible to grow food in extreme conditions?
Good afternoon, ladies and gentlemen. We are Mario González, Ángela Cruz, and Daniela Bañuelos. We're representing Universidad Nacional Autónoma de México, and we're out to present you the proposal Floating Agriculture for the 2021 Blue Sky Innovation Competition. We hope you enjoy our presentation.
The rising sea level and increasing population are the main problems that are sought to be solved with the creation of floating cities. However, one of these cities' most significant challenge is to achieve autonomy in all aspects. Food is one of the most important because according to forecasts, the Earth's world population will increase to 9.7 billion people by the year 2050. Therefore, food production will grow exponentially to meet the nutritional needs. The solution? Flooring agriculture. It is an infrastructure proposal that seeks to solve these problems by creating flooding spaces to practice sustainable agriculture, mainly using in situ produced materials, reducing food production's overall impact, and providing greater autonomy to flooding cities.
The construction and operation process consists of a series of structured steps where high-level technology and advanced engineering solutions will be implemented. Flooring agriculture is a project composed of three types of models: the bioplastic production, the printing, and the cultivation model. First, in the bioplastic production model, wastewater will be treated from the flooring city. It will be treated with 3 tubular photobioreactors. From this process, the main product obtained will be biomass for generating bioplastic. On the other hand, as a byproduct, treated water will be obtained for irrigating crops. Second, bioplastic threads will be used as raw material in the printing module to 3D print submodules for constructing the main one and the walls of the areas destined for cultivation. 3D printing technology is essential for increasing the efficiency of the constructive procedure.
Finally, taking advantage of the bioplastic production process, we will use the treated water obtained in our cultivation model. This will be through an efficient drip irrigation system, allowing us to initially grow crops such as tomatoes, carrots, and lettuce. The idea is that this proposal can be replicated and grow other crop types to satisfy the city's demand fully.
But how can we face the critical climatic conditions of the coast? The answer is controlling variables such as temperature, humidity, solar radiation, and CO2 concentration. This will be achieved by installing heating, ventilation, humidification, CO2 dosing, this by installing gas burners, thermal screens, and artificial lighting. Solar panels and breakwater walls included in the islands will be used to power the system, taking advantage of solar and wave power. Finally, it will have an automated monitoring system, which will require artificial and human intelligence.
The investment required to install the base system and give it proper maintenance, considering a lifespan of at least 50 years, implies a cost of $5,000 per year. However, the construction of the cultivation model will only take about 2 to 3 weeks. Then, the system will continue generating bioplastics that would not only enable us to build the system, but also gives us the potential to produce other resources needed in the cities, such as furniture and tools. This will substantially reduce the overall cost per year. In addition, production costs in flooring agriculture will decrease compared to traditional agriculture, and food production efficiency will increase up to 90%.
It is important to mention that this infrastructure solves traditional agriculture problems, including soil and water pollution, large amounts of greenhouse gas emissions, loss of biodiversity, and food insecurity. Fertilizers will not be used. The utilization of renewable energy and reclaimed water will be implemented. Therefore, there will be no simplification of ecosystems, and the people will be able to access to enough and a great variety of quality food. This will ensure meeting the Sustainable Development Goals of the 2030 Agenda.
As mentioned, from the planning to the operating stages, environmental, social, economic, and engineering indicators are included. This allows us to know the project's value given the benefits it will provide. It is a project designed to support inclusive and sustainable growth, the efficient use of natural resources, boost productivity, and improve life quality and social well-being.
Creating a space in which food can be grown must be considered a top priority to face the challenge of improved food security, especially in flooding cities. We are Flooring Agriculture. Thank you for your attention.
Thank you, guys. My first question would be, how many people would it take to man this kind of floating agriculture site? And how would they get there, and how long would they stay?
Well, we are considering that there will be floating cities for when our project will begin to be applicated. So there will be many people in these floating cities that are the refugees due to the rising sea levels. And we try to achieve autonomy through the use of certain automation systems in the crop system, such as sensors and actuators that reduce the number of people needed for the project. And as well, we are seeking to use robots that are instructed by commands and with the specific goals, not specific commands, by using artificial intelligence.
Okay, thank you. Alexis?
So if I'm understanding correctly, you expect these floating agriculture bases to support a floating city. So it's in proximity, it's nearby so that they can provide it to the city, right? So how much volume of food do you expect to produce from this floating agriculture, and how many people can it support?
Well, it depends on the food that we want to cultivate, because every type of food have a different time frame to grow. So it depends on that first, and that, and second, the per capita consumption of the location where the floating agriculture is settled. Because, for example, with lettuce, yes, we have that this takes about 6 to 8 weeks to grow. And for example, in Spain, the last year, the per capita consumption was about 3 kilograms per person. So we estimate that we can feed an amount of 4,000 to 5,000 people. But well, it's an estimation that we can use for every different type of crops that we want to use.
For these, have you considered how they would fare during hurricane event or a tsunami event?
Yeah, that's right. We have considered several environmental conditions that would affect probably, but we also consider that since our project is next to a floating city, most of floating cities projections are using a breakwater wall system, which reduces the overall impact of the waves, currents, forces. And in addition, there are certain areas in the ocean where hurricanes are less likely to happen, or less likely to have a considerable impact. So we have also considered that in places where there is like this considerable subsidence, so we have thought about, as they are modules, we can transport them around in order to mitigate the effects that a hurricane can provoke on them. So probably not avoiding it, but reducing the risk associated with it.
I would like to add that this is a problem where includes in general floating cities. So everywhere we can settle floating cities, floating agriculture will be implemented, can be implemented there.
All right, Joe, did you have a question?
Yes. So is it truly floating, or is there some sort of anchor beneath the surface? For instance, like an offshore platform, it's not necessarily floating. It's definitely anchored into the bedrock. So have you incorporated something like that, or is this truly floating? And if it is truly floating, what do you do to subside the turbulence from waves?
Yeah, that's a great question. Well, we have considered that it is truly floating on the ocean, since we have considered this possibility of moving around the modules in order to satisfy the needs of the population. And as I mentioned previously, we are considering the use of breakwater walls that reduce the overall impact of the wave currents. And in addition, we are also considering having some satellite information that gives us the current state of the currents in order to try to avoid the greater currents.
You mentioned you would be treating wastewater to water the plants. So where is that wastewater coming from? Is it coming from the cities?
Yeah, that's right. We are considering that as we have the floating city next to us, the wastewater that will be produced by them will be given in a system, and we will accumulate it if needed, and then pass it through the tubular photobioreactors, in which microalgae will grow. And we consider it like a win-win because we are treating wastewater and reducing the overall impact. And in addition to that, we are producing our main resource, which is bioplastic.
Are there any other questions from the judges?
I have one more. You mentioned that the lifespan of this structure is 50 years. Given the fact that we would need to use this technology if climate control had really gotten out of control. I'm sorry, climate crisis. I can't think of the word. I'm so sorry. The climate crisis has really gotten out of control. Sustainability is probably even more of an emphasis. Is there a reason you chose 50 years, and what measures could you take to extending that lifespan?
Well, we have totally considered ensuring the lifespan as big as it can. So we have considered not only using the biomass as a main source of the bioplastic, we have considered using several polymers, which have been used in several research papers in order to achieve greater strengths and improve the mechanical properties of the material. And to give it maintenance, we have designed our modules not as not as only one piece, but as submodels. And if there were to be a problem, we can change this submodel and 3D print another one and change it for it. So we will ensure that there will be no compromising the stability of the main structure, and there will be longer durance. This.
All right, Andrea or Joe, do you have any other questions?
No, I don't.
All right, thank you guys so much. All right, and finally we have Tec de Monterrey.
Can you see my screen now?
Yes. And just 1 second. All right, judges, are you ready? All right, Tec de Monterrey, whenever you're ready.
Megacities, the new cities. This will be the norm in urban spaces around the world. Good afternoon. We are Mauricio Paez and Benito Lozada from Tecnologico de Monterrey, and we will be presenting our proposal to the 2021 Blue Sky competition.
According to the United Nations Department of Economic and Social Affairs, it is estimated that 68% of the world population will live in urban areas by 2050. We chose megacities because they are one of the main consumers of water, energy, and food in the world. And these urban areas are also one of the main producers of waste and carbon emissions. This will require very complex infrastructure in order to satisfy future cities' needs.
Our proposal has been developed with the purpose of being feasible rather than disruptive, as countries around the world have shown to better adopt less disruptive solutions. The plan seeks to have efficient nodes in cities that use mostly renewable energy. These nodes are not thought to divide cities. They rather have the purpose of having a more local approach to megacities problems by being semi-decentralized from energy grids, wastewater systems, rural food production, and landfill systems.
Our proposal revolves around four main aspects, which are energy consumption, water use and reuse, food production, and waste management.
First of all, data from cities around the world show that energy consumption per capita is having a massive increase and will continue to grow in the next few years, and as fossil fuels continue to be the main source of energy in the world. Second, hydrological resources are limited and the effects of climate change will make it even hard to obtain the water. In third place, as urban population increases, so does the demand for food in cities, which are not known by their ability to produce food. Therefore, more and more food is required to be transported from rural areas to the cities. Last but not least, solid waste is usually transported to remote areas and it is constantly being produced as a result of a global consumption culture.
As a possible solution for reducing the dependency on the energy grids, the urban nodes are thought to produce a fraction of their energy by using renewable energy sources and by requiring energy efficient buildings from their design and construction.
As a solution for water scarcity in cities, it is required to reduce water usage by raising awareness in the population and by implementing efficient water treating and reusing systems. Raising awareness of citizenship is truly important because it would be worthless to have the best systems and equipment if citizens keep wasting resources. Also, it is known that the food production industry uses about 70% of global freshwater withdrawals for agriculture. As such, the nodes are thought to have smart urban farms, which are a new farming system that reduces 9% the use of water and require less energy than conventional farms. These smart farms are able to produce the optimum environment for better crops and can be repeated almost everywhere. This action will benefit cities in a lower water usage, less dependence on rural areas for food, and reduce carbon emissions from food transportation.
Another solution regarding food is encouraging citizenships toward adopting a balanced diet lifestyle that reduces the consumption of carbon-intensive foods, which also use a lot of water in their production. Finally, a solution regarding waste management is the further implementation of the 3R model, which is reducing, reusing, and recycling waste when possible. This model should be implemented through more laws and regulations. A good example of this is a highway built in Guanajuato, Mexico, which was made with a recycled plastic-based formula that enlarges asphalt life by 50%.
Modern technologies such as 3D printing in construction are also a waste reduction solution, as they require less resources and time when constructing infrastructure, and as a consequence, they reduce waste.
To wrap things up, our proposal seeks to introduce solutions for diverse problems regarding megacities by using techniques that aren't necessarily complex or expensive to implement, with the objective of making them as feasible as possible for their adoption in cities around the world. A journey of 1,000 miles begins with a single step, and we hope to be the first step towards a sustainable megacities future. Thank you.
Thank you, guys. So I guess one of my questions is, you're proposing separating the cities into smaller sub-cities. So how many people or how large are you thinking these nodes will be?
This is very dependent on each city because we know that cities are very diverse throughout the world. So we are thinking that these nodes can be created by existing neighborhoods rather than creating new divisions. And we're not seeking to divide, we're actually seeking to unify these neighborhoods into these urban nodes.
Thank you.
I have a question about the brains behind this operation. So you are explaining that in order to avoid becoming megacities, we're actually going to avoid the problem by breaking them down into smaller interconnected nodes. And you mentioned that a lot of the infrastructure systems, water, energy should be decentralized and kind of made a competency of each node. In order for us to decentralize, it requires expertise in each of those nodes to be able to run the system appropriately for what they need. Right now, we have a shortage of civil engineers who are professional who can go and do this job today. How do you propose that we have the proper amount of expertise to run these systems at a node level?
That's a great question. We are seeking not to decentralize entirely these nodes from the existing water systems, from the existing electrical grids. We're actually seeking more than decentralizing. We're looking towards a more local approach for water reuse, for a sustainable water use, and also for water reuse, which is not entirely complex. We're talking about gray water recycling systems, which are not that hard to implement with the right education. We're seeking to promote this, what do you call it? These techniques to more regular citizens.
You mentioned using the existing neighborhoods, and have you thought about the cost to bring a 50, 100-year-old home up to be what's considered energy efficient? And how is that going to be feasible for the individual owner?
We're not talking, well, actually, that's a great question. We're not thinking to implement a very disruptive measures in these neighborhoods. We're actually thinking with the existing infrastructure that it somehow might be able to introduce these measures. For example, in the existing neighborhoods, one does not need to recreate everything. I'm not explaining myself, but the model seeks to be very flexible, as in very old neighborhoods, the measures cannot be as hard as in new neighborhoods. But this would look for a more flexible model.
So kind of just do as much as you can. Is that what you're saying?
Yeah, that's precisely, yeah.
Have you thought about, I know you're trying to separate certain, kind of have many neighborhoods that are utilized differently. Have you thought about how to expand those by making it more modular in trying to accomplish the mission of your proposal?
I did not understand your question. Could you repeat it, please?
Yeah, like so, like for instance, you want to try to create different parts of the city that utilize different resources. In doing so and building those, have you thought about any ways to make it modular or growing without necessarily harming the environment that's already developed?
That's actually precisely what we are looking for, which is making it modular so that we could have energy production and water reuse by nodes rather than having a centralized power plant that is outside the city and an external water treatment plant. By reducing the distances between the infrastructure that produce energy and reuse water, for example, we're seeking to make it more modular and implementing it locally in these nodes.
How do you think city officials would respond to this kind of request?
Well, we're in need for motivation because in any way that we want to introduce any measures towards climate change, if there's not motivation in the governments around the world, there will be no measures, no matter how cheap or expensive they are. Our model seeks to make them cheap and feasible so that they are easier to integrate into existing cities. But there should be some kind of legislation that kind of pushes the governments toward taking more responsible and eco-friendly actions around the world.
I think you're in good company here on that one. I have a question that actually builds on that. So Eva asked, how would you influence a city official effectively? But in your project proposal and in your presentation, a lot of what you suggest also is at the mercy of the individual citizen, right? So the 3 R's: reduce, reuse, recycle, water consumption. You mentioned in your paper vegetarianism, and that it has huge benefits for water production and many other conservation methods because of the reliance on livestock, cows, pigs, everything like that. My question to you is, many of these concepts have been around for years. We've known about recycling for years. We've been preaching the 3 R's. Vegetarian and veganism have seen a spike in recent years, but there's still not much widespread adoption. So my question is, how is it that you're going to persuade the individual citizen to change their behavior?
Well, this starts, obviously, one cannot change the society without changing every one of the citizens. So we're proposing for education in countries. We're looking towards a more widespread kind of education around the world by using governments, by using advertisements, encouraging people, and actually looking for incentives for people to becoming more sustainable. I think that rather than punishing someone for not being vegetarian, for example, we could, inspire them by showing them the effects, and actually by giving some kind of commercial or tax incentive. I don't have a very precise solution for this. I just have the idea. And this is what I was thinking right now with this.
Andrea or Joe have any other questions? Alexis, any others? All right, thank you guys so much.
Well, thank you very much for your attention, and yes.
Thank you.